Good morning. Today we are going to see about problem on generator. So our main objective of the problem is to generate the calculate the generated EMF, and the parameters what we are getting from the problem. The problem statement is the number of poles is 4 and the number of conductors in the machine is 440 and flux per pole is 0.07 Weber and the speed of the generator is 900 rpm. So our objective to find the calculate the generated EMF of the generator, and the formula used to calculate the EMF generated is EB is equal to 5 ZNP divided by 60A. So there are two conditions at which we need to calculate the generated EMF. One is depending upon the connection and the what type of winding what we are providing. So depending upon the type of winding we are providing, it is divided into lap winding and wave winding. So if it is lap winding, the number of poles will be A equal to P is equal to 4. So which is given in the problem statement. So it should be assumed as A equal to P, that is 4. And if it is wave winding, it is a constant value, A is equal to always will be 2. So if you substitute these values in this formula, E is equal to 5 ZNP divided by 60A, we get the value of generated EMF in both conditions if it is lap winding as well as wave winding. If final result of the problem is, if it is lap winding 462 volts, if it is wave winding 924 volts. Today we are going to see a problem on DC series motor. So where the parameters given are the number of poles is equal to 4 and the terminal voltage is 500 volt. So the number of conductors Z is 944. So which is a series motor, has a total resistance of armature resistance and series resistance with the value of 3 ohms. So this is A, it will be 2, which is considered as wave winding, and the flux per pole is 34.6 milliweber and the armature torque is 209 Newton meter. So our objective in this problem is to calculate the line current and the speed of the DC series motor. So this is the formula for torque of the motor, 0.1595 Ia P into Z divided by A, and the value of back EMF EB is equal to V minus Ia into RA plus RSC. So with this formula we are going to calculate the line current value, and from these formula we are also calculating the speed of the motor, right? So in the solution, so we are substituting in this formula, PA is equal to 0.159 Ia P Z divided by A. So the final value from this line current we are getting is 20.122 amps. So this is the line current of the motor, and for calculating the speed of the motor we are using EB is equal to 5 ZNP divided by 60A. So N is the unknown value, so other values are known, so we are going to substitute this value and calculate the value of N. So here we need to calculate the value of EB value is unknown. So for that, V minus Ia into RA plus RSC. RA plus RSC is given, which is 3 ohms, and Ia we have obtained from this formula 20.122 and terminal voltage is 500 volt. So from this we are getting the value of EB, and from this formula we will be getting the value of speed of the motor N. So the final result is armature current is equal to 20.122 amps and the speed of the motor is 403.798 rpm and the back EMF is 439.634 volts. Thank you.